For me, like the real audit starts once you've wrapped your head around the protocol. Once you've looked at the code so much and you understand the code so much that you could just kind of like in your head, think through certain workflows, and maybe not every detail, but you could kind of work it through your head. Or if you start dreaming about the code, then you've reached the zone. But that's when the real audit starts, because that's when you can start thinking of bigger picture things. You could start think of various kind of economic attacks, game theory type attacks, because up until then, when you don't really have a strong understanding of the protocol, you're just finding like the same kind of thing that static analyzers can find. You're just finding little syntactical things, little informational or low issues. Maybe there's some high ones because the developer made a mistake, but they're not really that creative. Like those are the things that I really love to find.
Hello and welcome to another episode of Devs Do Something. Today's guest is Devtooligan, a pseudonymous smart contract engineer and auditor. Devtooligan is a mainstay in the Huff community and just recently landed a job as a security engineer at Trail of Bits. In this episode, we went really deep into Huff and why so many Huffors have had lots of success. That includes people like Devtooligan himself, Jay Trilly, who is the former co-host of this podcast, people like Vex, RevCell, many others that we mentioned in this episode. But why have they done so well? We explore that in this episode, and it might have something to do with Huff being a good education tool. But we also discussed Devtooligan's career path and how he got really good at smart contract security. If you're trying to level up as an engineer in the space and want some advice on what to do next from someone who has a really fast rate of learning like Devtooligan, we think you'll love this episode because Devtooligan is the man. So sit back, relax, and I hope you enjoy. As devs, we all love hackathons. They're a great way to boost your skill set, meet other engineers, and add to your portfolio of work. At Superfluid, we've sponsored many hackathons and decided to start putting on a hackathon of our own, the Superfluid Wave Pool. This hackathon is a little bit different though in that it's continuous. It's always open. You can submit any project built on Superfluid at any point throughout the month and have a chance to earn thousands of dollars in prizes depending on how your project stacks up. In just the last couple of months, we've seen dozens of teams build really amazing projects that run the gamut from Superfluid developer tutorials to full-fledged applications to a proof of concept Superfluid StarkNet implementation that we thought was really impressive. So we encourage you to check it out today. You can learn more by going to superfluid.finance/wavepool. That's superfluid.finance/wavepool. Happy hacking. But all right, we are here today with the legendary Devtooligan. It's good to have you here. We were saying off air that pretty much everyone we've had on who's a Huffer, aka into Huff, writes a lot of Huff code, has recommended that we talk to you and we do an episode with you. So I'm glad we're gonna get to do this. But before we get into Huff and security, congrats on landing a recent job with Trail of Bits as a security engineer. We'd love to understand how you got into crypto. I know you were a web developer before, but how did you go from just general web development into this wild west of a space?
Sure. Thanks, Sam. First of all, I just want to say I'm a huge fan of the podcast, and I've listened to I think most of the episodes, so it's really cool to actually be here talking to you. So I was a web developer, and I started my first job in web development was in 2016, and actually around that time, 2017, I did Ethereum hackathon, so that was my first exposure. But then I didn't really do much after that. I was super busy, just developing my web development skills. I was doing a Python, JavaScript stack, and I started out as the number one in-house employee for this kind of small startup, and I stayed with them for about 5 years until we exited. So toward the end of that time, I started getting a little antsy. I was kind of feeling a little burnt out, and I was super interested in everything going on the blockchain. So I started kind of messing around with Solidity. Of course, I did the crypto zombies and all that fun stuff. And summer of 2021, I heard about these mentorships. It's basically like an internship with Ethernaut DAO. And so I applied for one with Yield Protocol. And yeah, I got accepted. So the tech lead at Yield is Alberto Cuesta Cañada. And he was just an amazing mentor. He is so knowledgeable. He's kind of a bit of a crypto OG, and he is an excellent teacher, and he's just a really like kind person. So he kind of took a group of us under his wing, and yeah, I mean that led to an offer from Yield, and yeah, that's how I got into the space.
I love it. I actually remember those. And sorry, I'm choking on my drink of water I just had. But I remember those initial mentorship offerings from Ethernaut. I remember kind of just like lurking in the Ethernaut Discord and just like reading some of the content people put in. There was like really good Q&A sessions in there, I remember. But that's really cool. That's how you got your first, I guess, opportunity in the space. You had some development experience for sure before that. But what were some of the early things you worked on at Yield? Like, what were some of the initial? I'm assuming you were writing Solidity there.
Yep,
What
yep.
were some of the initial things you worked on?
Solidity from day one, and Alberto had put together a kind of a syllabus. It was like 10 different exercises that built on each other. So the first thing we did was we just kind of made a simple vault, and then we kind of built on top of that. We added some complexity. We turned it into like a multi-collateral vault, and then we started looking at like AMMs. We built our own AMM. So there was a natural progression, but I think around the sixth or seventh exercise, we started doing actual work for Yield. Okay. So, of course, it was just small things, fix some tests, whatever at the beginning. But, let's see, we started in August. I'd say by November, we were all working on fairly substantial stuff, whether it was like new features in a smart contract or, new kind of smart contract modules. But yeah, within a couple of months, we were up to speed enough at least to start. So yeah, that was kind of like the beginning.
That's really cool. It's really cool. You got to progress from just mentorship and just educational exercises into real work. And how did you get into low level stuff? Like, how did you go from just writing Solidity and maybe contributing at Yield to thinking, all right, how does Ethereum work? What's this Huff thing? Like, how did you get so into Huff in the low level?
Yeah. Well, that was so this was like kind of end of 2021, and then I started full time with Yield at the beginning of 2022. And this was like around the time that Soulmate came out, and there was a lot of low level stuff, a lot of Yule in there that I didn't understand really at all. And I remember trying to find resources on it. There was a bunch of really super old videos, and I also found some tutorials. And I must have spent maybe like 2.5 weekends, like solid weekend, just trying to go through these tutorials. And man, I was just like banging my head against the wall. I didn't really get it. I kind of memorized some stuff, but I didn't really have an understanding. And I can't remember what triggered it, but Jet Jadeha reached out to me, and he was like, "Yo, man, you should try Huff." And I was like, well, I was planning to look at lower level like bytecode stuff after I learned Yule. I thought that would be like a good progression, learn Yule. And then he's like, no, you got to do it the other way around. He said, there's a guy named Dylan Keller. He's a bit of an OG himself, an index finance guy. And he was involved a lot with kind of bringing Jet up to speed on Huff. So he's like, yeah, Dylan told me the same thing. You've got to try it. And oh man, that really changed my whole trajectory because I spent like not even a half a day, like 2, 3 hours doing a very basic Huff tutorial. And it just all clicked. It all made sense. Like, started to understand about the stack and the memory and how everything's kind of based on opcodes. So it was just amazing, and then I went back to the Yule stuff, and I'm like, oh, I get it now. Now I see what they were trying to say here. So that turned me into a Huffer, and yeah, I mean, from there, like, um, there was this kind of like grassroots movement. Like, Jet really brought a bunch of people together. He didn't only reach out to me; he reached out to other people, like RefCell, and then there started to be a little bit of buzz about this, like, rewrite of the Huff compiler in Rust, and yeah, so I wasn't involved directly with the development of that, but I was like there using it. I was a tester, and then once we got the compiler out, we put out basically like Huff version of Soulmate. We call it HuffMate. So I was a very active contributor to that. I worked on the ERC20 implementation with RefCell, and yeah, I've just kind of become like I'm a very vocal advocate for Huff. Like I'm a big fan. I'm kind of like a cheerleader of Huff, and I don't know. I've just kind of I don't know. I'm almost a little bit like a DevRel, like just kind of fell into that role just because of my enthusiasm. But yeah, like that's kind of like how I went from not knowing anything to kind of being. You know what they Jay Trilly calls me the chief pharmacist because I'm always Huff pilling people.
Yeah, with Jay Trilly's the man. Him and I actually together we initially launched this podcast out of Superfluid, where Jay Trilly used to work here, but I still work at Superfluid.
I know
Um,
all of that, and he's talked about you a lot. And he was one of my early mentors when I first switched to Huff. Like, he took the time to walk me through a couple of basics, and he was just very patient and very generous of his time and his knowledge. So, yeah, he was definitely one of my mentors along the way. And yeah, I still, talked to him a lot. And I know he was at Superfluid, and I actually did an audit of Superfluid, and that is a pretty complex code base. I'll tell you that.
there's a lot going on. There's a lot you can do with it. It's powerful. That's why Jay Trilly and I got into it, and I'm still into it. He was into it for a long time. Um, but yeah, Jay Trilly, I'm sure you're listening to this. You're the man. Thanks for
He's a
helping out
man.
Devtooligan. But okay, so we've had a couple episodes that have centered on like low level stuff. We've talked a lot about Huff on some other episodes, but why should people learn Huff? Give us the we're usually a very anti-shilling show, right?
Yeah.
We don't let people show here, but this is unique because I think there's a lot of really good educational pieces in here about why you should learn Huff. But I'll let you give the pitch for Huff in your own words.
Right, right. Oh, I didn't really have the pitch ready to go. I didn't want to do any
It's
shilling. Let
okay.
me think. I mean, basically, like, I was just looking up something that I wrote recently when somebody asked me to do the same thing. They said, "Give me the pitch on Huff." Okay, so Huff. Huff is really not so much a language as it is kind of like a thin wrapper around pure EVM opcodes. So, like, there's certain complexities and certain kind of um, challenges when you're writing pure, just bytecode that Huff helps out with. So, as I kind of mentioned earlier, it's a really great learning tool. I think within a very short amount of time, you're going to develop a deep understanding of like exactly how the EVM works, stack, memory. You know what? It's even going to kind of increase your understanding a lot about Solidity functionality because when you're writing Huff, you don't have all these guardrails that you get with Solidity, and you start to appreciate them. So you actually learn about the EVM, you learn about Solidity, and as I mentioned earlier, like if you're interested in learning Yule, well, I would say stop what you're doing, learn a little Huff first, and then when you go back, Yule is going to be, a lot more intuitive. So that's kind of the pitch for the education. As far as like real world applications go, I mean, it can be used for writing hyper optimized contracts, and that's like the original reason that Huff was developed by Zach Williamson and his team at Aztec Protocol for writing like a very optimized elliptical curve math library. And but you know what? It's not like you'll, in the sense that you could just inject a little bit of it into Solidity, a Solidity contract. It's all or nothing. So there's not a whole lot of use cases where I can look you in the eye and recommend that you write an entire contract out of, low level bytecode. No, like, I mean, there's just so many foot guns. I mean, that's why we have Solidity and these other, higher level languages, is to provide that type of protection. And I don't know, it would be like, I don't know, like if you were to like attach like a lawnmower motor to your skateboard and be like, yo, can I go ride this on the freeway now? You know what I mean? It's like, you don't want to be doing that, and you don't want to be using, I would say, pure bytecode to deploy your contracts. There could be some other, I think, uses for it in the future, but like as a general rule, like, I don't recommend using Huff for your production contracts.
Makes sense, and I've heard that before from other people. I love the the lawnmower motor analogy. That's
I
actually
just thought of
fantastic.
that. Yeah, it was
That's
like,
good.
yeah.
That's a good one. So what are some of the things then? Because this is actually maybe worth unpacking. What are some of the things that you appreciate about Solidity and higher level languages now? Now that you've gone really deep into the low level, like what has Solidity done really well?
Yeah. Well, I mean, there's just so many things. It's hard to. There's so many. I mean, there's a lot of debate as to whether they've done it well, and I've heard a lot of criticism of Solidity in general, and even sometimes of it gets extended to the Solidity core team, and I don't agree with that at all. I know a lot of the Solidity core guys. They are super smart. They're working their ass off, and they're doing good, solid engineering work. And I mean, decisions are made along the way, and don't always things don't always work out. Uh, as maybe as perfectly as you had hoped, or unforeseen things arise. But like, just in terms of examples of some of the guardrails, right? I recently did a seminar for Spearbit DAO about Huff, and it was a 1 hour seminar, and we spent almost so it was basically just me going through this example, right? It was like simple store, where you can like store a state variable and you can get it. Super simple. So we spent the first over 30 minutes, maybe 35 minutes, just getting to the point where you've taken the 4 byte function selector out of the call data, and you've kind of routed it to the proper function. That's all we did. We didn't even execute any functions. All we did was this like initial routing of saying, oh, the first 4 bytes is the getter. We're going to call the getter macro. We didn't even get into the getter macro, but just that whole kind of routing at the beginning, and the parsing of the call data, that took me 35 minutes to explain. And that's an example of something we don't even think about when we write Solidity. It just happens, right? So, there's an example. I mean, another good example of things that people probably don't think about is, like, I'm sure you've probably heard the gas optimization trick of add payable to your functions to save 20 gas, or I don't know how much gas it is, but save some gas by adding, this one keyword, payable. And I remember learning that, and I was like, okay, that's weird, but yeah, whatever, saves gas. So once you learn Huff, you realize the reason for that is you have to actually write some extra code if it's not payable. If it's not payable, you have to write code that says, okay, was any ETH sent over with this transaction? Yes, well then revert. So you have to write that code to make it not payable. So if you don't, if it is payable, then you don't have to write that code. So that's where the gas savings comes in. So there's just like a couple examples. I mean, safe math is huge. Yeah, there's a lot of things like that.
Interesting. So there are things that actually were written into Solidity for a reason, and all the optimizers, even though they want to optimize for, maybe they're optimizing for gas costs, but in reality, Solidity developers, as they're actually not Solidity developers, but the Solidity core team, as they're building this language, they just have a different set of trade-offs they're probably focused on when compared to someone like you really pushing the limits with Huff and things like that. I think that's maybe the right way to think about it. Um, so when it comes to Huff and in the Huff community, are there any advanced patterns or new things you'd like to see the Huff community do that maybe haven't been done yet?
I mean, as far as patterns go, nothing really comes to mind. I mean, there's a lot of, you always see very creative solutions to various CTFs and optimization challenges that come up, and I love seeing all the creativity out of those. But like, I mean, for the most part, what we've seen is just highly optimized versions of stuff that's already out there. Now, what I think could come someday, but I think there's a potential for, is a couple of things. Like one is, well, there's one huge area that I think is untapped right now, and Dylan Keller, who I mentioned earlier, has said that he wants to like write this series of articles about using Huff to create virtual machines. Okay, there actually is one right now in production used by Nested Finance. They call it Hypervisor VM, and it's actually like an EVM written on the EVM. So like it allows you to like pass arbitrary bytecode and have it executed. So there is one example, of a virtual machine written in Huff. But I think that you can really apply that to any kind of virtual machine. Like actually, back in the day when I was a Web 2 dev, at one point I became like this state machine maxi. I was like, I wanted to turn everything into a state machine. Like state machines are pretty cool. And there's like this even more fancy version of state machine called state charts. And yeah, I mean, you can really encapsulate a lot of logic into a state machine. And at the end of the day, pretty much everything is basically just a state machine. So I still have I still have that kind of a tendency, but yeah, I'm not I'm not trying to fit everything into the state machine box anymore. But I think that you could use Huff to basically, like, there's this one library I used to use a lot called XState, and it allows you to create these really cool state machines. It was a JavaScript library. They also had a Python one. But like, I bet you could do. I think you could. And this has been like on my list of to do projects, but I think you could create basically a version of XState that lives on chain, and it's like a state machine factory. So you feed it some parameters of like the different states and the different transitions and etc. And it will kind of basically just crank out a highly optimized state machine for your use. And some of the cool stuff that you could do with something like that is you could just circumvent all of the kind of the like, I guess, the solidity conventions, like especially with call data, right? Like right now you got your 4-byte signature followed by your, all your arguments are padded to 32 bytes, etc. I mean, you could just have your state machine change, states by like passing it like one, you and 8, you just pass it a 1 or a 2 or a 3. And so there's, I think, some creative things interactions you can have with a non-standard, non-typical contract like that.
Interesting. The state machine maxi, the former state machine maxi.
I'm a recovering state machine maxi. It's true.
I love it. And one thing about people that have gone very deep into Huff, right, that have really tried to push the limits with this low-level stuff, like yourself, like Vex, who we had on a few months ago, and Jay Trilly, is that it seems like you guys have really had a high, like your rate of learning is extremely, extremely high. You're able to learn things extremely quickly. Like in the last year or so, like a year ago, you said you started at Yield full time. I mean, how many things have you learned between now and then? It's actually kind of incredible. I can say the same thing with Jay Trilly as well, right? It's really, really incredible how fast you guys have developed in the space. So why do you think so many Huffors have had the success they've had? Is there just something about like being together in a community that's powerful, and maybe Huff is just like a thing that brought you together, but it's actually more the community and the mentorship? Is there something about like the actual learning of the language itself that's helpful? Like, how do you see that? Why do you think so many Huffors have had success?
That's a really interesting question. I totally agree too. Like, there's so many gigachads on the Huff core team. um, Vex, as you mentioned, RefCell. Um, he goes by Medea. Man, I'm gonna miss all of them. There's Mathis GD. There's so many. Fran. I'm sorry if I forgot your name, but there's just so many people who have done so much for the Huff community, and that's definitely a huge, huge perk, I'd say, or a huge, reason that I think people get involved. But if you kind of look at it just at Huff itself, I think it's first of all, there's a certain level of complexity just to kind of be able to wrap your head around it, right? So there's like a little bit of a barrier to entry. And then once you kind of get into it, it's just such a fun. I mean, somebody said recently, they said Huff is like writing bytecode, but with 100 times the improved DX, right? Like it's just so fun and it's so powerful. And if you get like very intellectually curious people and you give them something that's kind of fun and powerful like this, I think they really dig it and they really go far with it. And I think that might explain why Huff attracts the kind of people that it does. And I mean, you're right. Like it's so funny. Like right now, there's been a little bit of a lull in the kind of the core maintainers because all the core devs have recently gotten like super awesome jobs. Both Vex and RefCell are working in Optimism now. Madea, oh my God, he works for Aztec. Like that's like every Huffer's dream job, right? Like every Huffer is like, oh, I would love to work at Aztec with Zach Williamson. He's like the hero. The original inventor of Huff. So he got the dream job. He's working over there. Jay Trilly just started working with Fuel Labs. The list goes on. So I think, yeah. There's a couple other jobs that I'm forgetting that people got recently. So there's kind of been this lull because all these talented people have been kind of scooped up.
Yeah, it's really interesting. It's one of the more successful, I guess, like communities, or maybe it's actually one of the more successful nerd snipes that have existed in this
I
space.
think that's a great way to put it. That is such a great way. Huff is like the ultimate nerd snipe.
Yeah, it's done well as a nerd snipe. Future prospective nerd snipers should study the Huff community. Maybe they'll learn something. Okay, so let's move on to security a little bit, right? So you've gone through a path in this space where you started working at Yield after that mentorship. You got deeper into Solidity. You got into the low level stuff, and I'm sure working on a DeFi protocol, like security is part of your daily thought process as you're building things. I was going to ask you how you'd recommend other people get better at security, but maybe what's a better initial question is how have you evolved in terms of someone who thinks about smart contract security over the last year and a half to 2 years?
Yeah, well, looking back to when I first started the mentorship with Alberto, he emphasized security from day one. So that was always something that was an important factor when developing smart contracts. And I would say that it's really Alberto who originally sparked that kind of interest that's kind of become this passion for security. Just because like from day one, that was something that he emphasized. And I think it's really telling that so did the mentorship starting in the summer, kind of full time by the end of the year. So around May of 2022 last year, um, I had gotten really interested in joining Y Academy. They have this fellowship, and I applied for it. I was really interested in joining, and just based on what I learned working with Alberto, just based on that knowledge he kind of transferred to me alone, I was able to get through the very kind of intensive interview process that they had. So at that point, I hadn't done anything like Securium. I hadn't really done much outside of just, develop smart contracts working with Alberto. But because, security had always been such an important consideration, I really just learned a lot just from on the job, I guess you could say. And it's also just kind of so interesting too, because it adds this whole other vector to kind of optimize for. You can optimize for runtime gas, you can optimize for readability, sustainability. And then now, there's this very important other vector, security, that, is the most important vector actually.
Absolutely. So for you, you had this mentorship that helped you out a lot. You develop smart contracts every day that help you keep security top of mind, and you're actually building things with these principles in your head the whole time. You get into this academy that's really useful for you. Let's imagine that like you're talking to our audience, some of which are early career devs. Maybe some of them are just starting to write smart contracts. Maybe they just landed their first job writing Solidity. What do you recommend for them if they want to get better at security and level up in this area? Is it just find somebody to help mentor you? Or are there things they can do on their own? Like, how would you recommend that they um, get better?
Yeah, yeah. I mean, absolutely. So, I mean, I guess kind of like maybe it would make sense for me to just kind of go through the rest of the story since Y Academy. So like, Y Academy was really where I learned even what an auditor is, what an audit is, what an auditor even does, like I hadn't really thought about it too much prior to that. I had been on the kind of the consumer side of getting an audit, but normally I would just kind of see the end result of that and work to implement the fixes. And I had never really thought about what an auditor does. So at Y Academy, they just kind of throw you onto these audits and kind of let you figure it out. And yeah, I mean that's something we can talk more about too, like kind of what I kind of what I developed, this mental model of auditing. But in any event, I kind of like that's where I first started doing some auditing. I loved it. Okay, it used a different part of my brain, and there's this like kind of excitement that you don't get from being a developer. Like when you've kind of when you've kind of identified a potential exploit and you're kind of honing in on it and you got this little POC going and you're kind of drilling down, and then finally when you see like your test pass and like all the ETH go into your attacker's account and the test is green, it's such a cool feeling. It's just like such a rush. So there's that kind of aspect to it, but it's just also, like I said, it's a different part of your brain. It's kind of big picture thinking, like just kind of thinking it from a high level. For me, like the real audit starts once you've wrapped your head around the protocol. So once you've kind of like, once you've looked at the code so much and you understand the code so much that you could just kind of like in your head, think through certain workflows, and maybe not every detail, but you could kind of work it through your head. Or this happens sometimes. If you start dreaming about the code, then you've reached the zone. But that's when the real audit starts, because that's when you can start thinking of bigger picture things. You could start think of various kind of economic attacks, game theory type attacks. Because up until then, when you don't really have a strong understanding of the protocol, you're just finding like the same kind of thing that static analyzers can find. You're just finding little syntactical things, little, informational or low issues. Maybe there's some high ones because the developer made a mistake, but they're not really that creative, right? Like those are the things that I really love to find, is like these kind of very creative exploits. So, um, yeah, I mean that was the Y Academy experience, and from there, I just started doing a ton of auditing. I did a lot of C4 Code for Arena. I did some Sherlock. I did an audit for Y Academy. Later, I joined Spearbit DAO. I did an audit with them, but I was just getting so burnt out on doing like yield all day and then like auditing stuff nights and weekends. It was really rough. So I actually kind of toward the end of the year, like September, I kind of pulled back on the auditing, but I really loved it. And I had a good friend who was also Y Academy, Ben Sams, and he he got a job with Trail of Bits, and he kind of referred me over. He encouraged me to apply, and yeah, I did. I mean, the rest is history, as they say. But that's kind of like been my curve. So now, like with that in mind, to finally answer your question about some advice for a newcomer, I think there's a lot of resources out there. I mean, I think like once I did go through Y Academy, I started reviewing a lot. Like actually, Trail of Bits has some excellent resources. I think we just released it as its own website, but there's this thing. It used to be called Building Secure Contracts, but now there's just like a secure contracts website, and it contains a lot of like educational information. I don't know, like if you call it tips. There's even like some exercises. So there's a little bit of a curriculum on there. And at the end of the day, though, like in terms of upping your audit game, I think it's just about doing it. Like it's just about actually, you know, doing getting your reps in, I guess, and by a rep, it could be a C4 contest, it could be an audit, or it could just be something you do on your own where you try to take some sort of code base that you've never seen before and gain a deep understanding of it. That's really what the rep is. The rep is doing that. And the more you do that, the better you're going to be, the quicker it's going to take. You're developing all kinds of like pattern recognition, uh, you know, um, kind of mental models that will help you to recognize things quicker the next time. So the first time you do it, it might take you 40, 50 hours to really understand, like, I don't know, a lending protocol if you've never looked at it before. But then I guarantee you, after doing like 10 lending protocols, that 10th one is going to be a lot quicker than the first one. So I really think to really get from like that beginner, like, okay, I know all the Securium 101, best practices, to somebody who's, a good security researcher, you got to put the reps in.
That's interesting. I think that's really good advice. And the nice thing about this industry is that every single protocol you'd want to look at it's there. You could just go look at it, just pull up the GitHub. Like you could even like get the repo locally and just mess with it there, right? There's nothing really stopping you. The information is all there. Now, the challenging thing though, and this is like one of those things that's probably very hard to teach. You can learn it, but it's probably different. It's probably difficult to like turn this into some direct do this then that curriculum. But like, what is your mental model of doing an audit, right? You mentioned that you have this process where you just like front load all of this information about this code base into your mind, and then that's when the audit starts. But like for you, can you walk us through just like what a typical audit looks like in
Yeah.
your case?
Yeah. I mean, I've kind of like touched on a lot of these things. But I mean, basically for me, like an audit starts with going through the documentation and really trying to understand the concepts. And there's kind of like this debate out there, like, oh, we shouldn't use documentation, we should just look at the code and try to figure it out, because like the documentation is going to affect our perception, and it might cause us to miss something. I mean, that's true, but like I think the benefit you gain of uh, getting up to speed on a new code base far exceeds that kind of risk that you're taking by reading the docs. So read the docs, get to know as much as you can, um, and then it's a matter of kind of just drilling into the code. Now, there's a lot of uh, ways that you can drill into the code. And I used to not be a big proponent of like doing static analysis. I just felt like it had so many false positives, and it wasn't really bringing up a lot of beneficial things. I wanted to just, jump into the code, but I've kind of changed my view on that. Like, even before I started with Trail of Bits, I started getting into Slither, and one of the things that Slither has is this thing called printers, Slither Print, and so like Slither printers allows you to like look at contracts and functions in different ways, which was actually something I was already doing manually. I was already like looking at contracts and trying to figure out what were all the external functions that were not permissioned functions, etc. And so static analysis, that was kind of like my gateway into really getting it a lot more into static analysis, was these printers, these kind of like ways to slice and dice the data. So yeah, now I am a proponent of running the static analyzer, running the slither, going through all the findings. It's probably the case that you you you, you're going to have some false positives in there, but that's just part of the job. And so it can also be very useful too. Um, there's a lot of kind of creative things you can do with building your own detectors, and I've kind of gotten into that a little bit too. But in terms of like just the standard audit, so I think that is a great way to start out. And then, yeah, I mean, it's usually I'll start with some contract. Like, let's say there's a bunch of different aspects. Like, let's say there's like an AMM and a lending contract, and I don't know, some kind of accounting contract. If I'm just like completely at a loss, I'll start with something that's familiar. So I've done a lot of work with AMMs. I'll probably start with the AMM contract, and I'll like drill down all the way till I'll do like a depth first search where I'll drill down to like some kind of contract that's not inheriting anything. And then I'll just go through line by line, kind of like taking notes. And, I'll work my way kind of back up until I've kind of looked at every line in the AMM, for example, and I'm taking notes like, oh, there might be some reentrancy here, or oh, this would be a great kind of invariant to run echidna on, do some fuzzing. I'm just taking little notes, but I'm not like doing a deep dive on them at the time, because one thing I've noticed is if you have a question early, it may get answered a little bit later. So I don't really go down the rabbit holes as I see them. I just kind of list out the rabbit holes. And then once I've kind of gotten to that, gotten through the AMM, I'm going back to those notes and I'm doing the deep dives. And yeah, I mean, that's kind of in a nutshell how I kind of go about it. And depending on the size of the protocol and kind of the size of the team, I may just go through the entire protocol at once and then kind of start doing all my deeper dives, or I might kind of take it, section by section. If it's a really big protocol, maybe I'll be happy to start working on some of the POCs for the AMM, for example. So
Interesting. Yeah, I appreciate you walking our listeners through that process. It's fascinating for me to listen to, just because it sounds like it's interesting, right? You get to understand how all these different systems work, I find it also interesting that there are some, I would imagine, almost checklist style things that are part of an audit, right? You're going to run static analysis on this, and you're going to use Echidna on that, and you're going to make sure that these specific patterns aren't in there, like the Securium 101 stuff. But every single auditor, I think, has their own process and unique way of coming to an understanding of how a code base works. And I find it interesting to hear someone like you talk through that. So that's fascinating to me. But on the side, okay, if we flip back over to the builder side, right? After doing quite a few audits and seeing lots of different patterns from lots of different devs and doing your own development work yourself, are there any patterns or mistakes or semi-dangerous things that you still see often that you wish people building smart contracts would stop doing? If there are any things like that, we'd love to hear them.
The first thing that comes to mind is just documentation. I think that like it's just so much easier for the auditor if there's good documentation in place, and if there's not, it makes it a lot more difficult. So, I think documentation is a big area for improvement. Um, I mean, there's a lot of things you could do to prepare. I think that actually there's a really good Trail of Bits article about preparing for an audit. Maybe I can send you a link and we can like put it on here with a couple of the other things I mentioned too. But like thinking back to that article, I mean, it's basically like you're optimizing for getting the auditors kind of up to speed quickly and allowing them to focus on the bigger picture. So you should be the one to take out all those little low hanging fruit, you know. You should be the one to be sure the code is peer reviewed, it's got tests, if it's got some fuzzing, even better, you know. If it's got good documentation, that's going to be a huge help. But I've seen some amazing documentation that includes like all kinds of helpful diagrams, even like video walkthroughs, you know, like, the developer will like kind of walk through certain complex parts of the code. All of that stuff is super helpful. And yeah, let's see, I mentioned like running Slither in advance and triaging all that. And I think like, devs in our space have gotten really good at writing tests, but I think that like now we're on the verge of writing even better tests, like starting to do more invariant tests with like, Echidna or Manicore. Also like, yeah, I mean, just in general, like I think that what we're going to see is that this kind of 2023 are going to be more like the year of the invariant test. Like that's going to become more of a mainstay in the development process this year, and we're seeing that. We're seeing that those kind of competitions around writing properties pop up, and that's actually it's funny. Like I got a funny story. So like when I told you that I interviewed with Trilobits, and man, the final interview was really intense. It was just like a 2 hour technical grilling by two of the senior people who were very extremely knowledgeable themselves, and they basically picked out every piece of information I had in my head, as they had like a perfect map, like a mind map of my brain. So when I started, they sat me down and they said, "Okay, we know you're really good at this, this, and this, and here are your weaknesses." They already knew what my weaknesses are. So one of my biggest weaknesses was property testing, and fuzzing and to some extent, symbolic execution testing. So yeah, they've been having me, in addition to shadowing audits, I'm also spending time kind of upskilling my property testing, and so yeah, there's like some amazing videos that I've been watching. It's like there's a fuzzing workshop that was just put out by Trail of Bits where they do like live streaming fuzzing using Echidna, and that's been like extremely helpful to my education. But yeah, I've been. I think this year I think this is gonna kind of be like the year of the invariant testing.
That's interesting. Yeah, I started to go pretty deep into invariant testing as well in my day-to-day work, just helping people building on Superfluid with stuff. There's a framework that our CTO put together that's been helpful for us. So yeah, I'm with you there. I'm learning a lot about invariant tests. But on the topic of tooling, there's a lot of hype around AI tools right now. Right? I even think I saw one audit firm pop up that said that like their whole competitive advantage is like they were using some kind of GPT thing to aid in their audit process. How do you think AI is going to, and I guess some of this other stuff like Copilot and um, new models that are trained on smart contracts and in our space? How do you think that's going to impact what you do as an auditor, if at all?
I mean, in some ways, it's kind of hard to say right now. It's a new field. I mean, I'm like everybody else. I've been loving Chat GPT. It's super fun, and I spent a ton of time. I got the premium package going. I definitely use it a lot, but I use it with kind of some caveats. It's kind of unclear how these large language models, how far they're going to take us. Like, it seems like it's a very promising field to explore. And there's definitely some things that it's good at right now, like actually we just implemented this thing in Slither. It's called Slither documentation. And you basically just run it and it'll add all your NAT spec for you. It'll like figure out what the code is doing and write your English documentation. It's actually really good at that. So I mean, that is like I think a very low risk thing that it can do right now. But I mean, in terms of can we just feed it a smart contract and it picks out all the vulnerabilities? I don't know if that'll ever happen. Maybe, maybe not. I mean, I don't know if that'll ever happen with GPT. I mean, there's been a lot of arguments that I've heard that indicate that it just might be too complex. And Trailbits actually has an amazing machine learning team. And yeah, I mean, I'm just kind of starting my AI arc here. Like you know, this is the beginning. I don't have a lot of deep knowledge about that other than, having some fun with ChatGPT, but I'm super interested. I'm super excited to kind of be at like the intersection of AI and blockchain security. And yeah, there's a lot of like really, really like world class, AI machine learning experts at Trailbit. So I'm just feel super fortunate about that.
Yeah, the Trail of Bits team sounds very impressive, and I'm with you on. I'm unsure how far large language models are gonna take us to. A lot of the AI hype on Twitter feels very similar to like peak crypto conversation. There's I'm starting to see a lot of parallels, but we'll see. We'll see. I suppose it's been fun to use for sure. Another thing that I saw you, I think you replied to a tweet the other day that it was somebody talking about how writing production ready code isn't that exciting. It's boring, right? Production ready code, it has to be so secure. It can't take that many risks. But just spewing inspiration in the form of random code on chain is sometimes just fun. It's just sometimes what you want to do. And your reply to that, I think, was interesting in that you highlighted that that's actually the way you learn a lot of new concepts, by just exploring, seeing where things take you, and experimenting on like the most extreme frontiers. Actually, even if it's not done in the name of high productivity, it's where learning happens, right? So, can you unpack that a little bit and maybe just talk a little bit more about how you see some of this experimentation?
Yeah, yeah. I think I remember that tweet. I think it was kind of like it was kind of at the end of some kind of messing around we were doing with basically adding logic and like not just like variable assignment, but like all kinds of like function invocation and basically adding like the entire logic of a function inside an emit, like when you emit an event. So like, well, it all started I think with art gobblers. So like there was a couple of events where like I think transmissions 11, like like if you say like uint x equals 6, that evaluates to 6. So you could do like to kill two birds with one stone by putting that in as an argument. If you wanted to put that result, that 6 in there as an argument, you could put as your first argument, x equals 6. And what you've just done is you've assigned 6 as the value of that argument, and you've also assigned the variable x to 6. There's 6 to the x. So anyway, we noticed that, and then we started kind of joking around. I think it was with horse facts. Let's see how far we can take this. Let's put the whole kind of function logic into it. And so we did that. That was kind of funny, haha. But then several months later, it kind of came up again. I think it was Ross that brought it up, and we started taking it even further. And I'm like, all right, I'm putting up a bounty. Who can write an entire ERC20 contract where all of the logic is contained within, emits? And I think it was Daniel Forge who ended up being the winner of that. But like, yeah, that's the kind of experimentation you're talking about. And the comments were mixed, right? Like half the people are like, "Oh, that's so cool and funny. Oh, what about this? What if you did this?" And just kind of rolling with it. And the other half were like, this is, so ugly. Oh my God, what are you guys doing? Stop doing this. This is a bad idea. And so that was kind of like, there was like all these different kind of comments. And yeah, I mean, I think I'm a huge fan of this kind of experimentation. I've done a lot of it. If you go through my GitHub, I got all kinds of crazy stuff in there. And I think that it provides two things. Okay. One is like, it actually, I think, is conducive with uh, innovation. Okay, like not always. A lot of times we're just joking around, but like that's kind of, I think, how new kind of concepts and new patterns emerge, is by trying to do a bunch of trying to break things and trying to it's almost like a test pilot, right? Like flying around. Like we're trying to crash the plane so that it doesn't crash when you're in it. So I think there's this. I think I'm a huge supporter of just like that kind of experimentation in general. But then I think there's also this like it's that's what the tweet you're referring to. There's this like kind of relief, is that the word I'm looking for? This like you're sitting there, you're grinding out these like super safe, and which means super boring, right? Boring is safe. And so you're doing your best to like just write these very as boring as possible safe contracts. And it feels fun to like kind of like let loose and just like do the exact opposite and write something super unsafe. So there's a little bit of just this kind of like letting loose that I think we were kind of alluding to in that tweet. And a lot of people really, especially, yeah, I really resonated with that because, yeah, it can get to be a bit of a grind when you're just doing hours and hours of Solidity every day, and it's just fun, it's just fun. Like I did this one thing where there's this thing called an access list, where if you send an access list with a transaction, it will make certain storage slots, whatever slots you specify, it'll make them warm. So anyway, long story short, I created this library where you could basically communicate, uh, as much data as you want through an access list, because it changes those hot and cold slots into kind of binary. And so if you send 256 of them, you can trigger 256 bits. So I created this whole library around being able to send to communicate with a smart contract via the access list, making slots warm or cold. So, just stupid stuff like that. It's fun to do, and you learn a lot too. Like in the thing about emitting events, it's really kind of stuck in my head now that when arguments are being evaluated, it goes from right to left. So if you have something that's dependent on something else having gone first, you need to have the appropriate order. You should put the thing that goes first on the right, and the other one on the left. So yeah, that's just kind of the whole thing with the experimentation. It's fun, but I think it's also worthwhile, and it's also just kind of like a break from what can be monotonous. Just kind of plugging away sometimes. Sometimes it might feel that way.
Yeah, there's something so interesting about this that I've been thinking about a lot lately. And I think it's that like a lot of people, if you go on Twitter, if you just, if you I don't know, if you go on the internet at all, everyone's talking about how you have to look for like these most important problems and solve like the biggest, most important problems you can. And you can only focus on those things. And you got to like pick this super long term goal and you got to go for that. And I think there's a place for that, right? Like in terms of like the actual products you decide to build, things you want to take to market, all that stuff. Like, yeah, you want to solve important problems because those are things that are going to have impact, and that's good. But there's definitely a dark side to that. And that if you're only focused on these huge, important problems you want to solve, I think, you end up maybe having a little less fun. And I think that there's actually something to be said about just playing around and experimenting and going wherever curiosity takes you. Because to be honest with you, like the most important problem in 3 years, like people might not even be able to articulate what that is yet because the space might move so fast. And you can't really predict what the future is going to hold. And I think that there's something about you, Jay Trilly, Vex, Refcell, this group of people that are into Huff and just playing around on chain. Like Jay Trilley's got his cursed Solidity Fridays he does every once in a while, where you guys just try to break stuff, right? It seems like you're having fun. And I think that there is some connection. This is just my hypothesis. I think that there's some connection between your guys' willingness to just play around and your rates of learning. Because again, like every single one of the people we've kind of talked about in this conversation, you've all learned so much in such a short period of time. You've come a really long way in a short period of time. And I don't know. I think if you're maybe listening to this, one thing to keep in mind is that you can just follow curiosity and play as long as you're producing things in public still. I think it can work really well. So I appreciate you telling that story and unpacking that tweet because I think it just made some things click in my own head. So thank you.
Yeah, I couldn't have said it any better myself. I think that was very well said. I think that I only kind of learned that once I got into Web3. So I don't know if it's definitely like a Web3, Web2 thing. I don't know if it's just a coincidence. I just get lucky. But since I've gotten into Web3, I've just been kind of like following my passion, Oh, like Huff looks cool. I want to get into it. Oh, I'm super digging doing, security and get deeper into that. And, if I could go back to a young Devtooligan, I would say, hey, I would tell him exactly that. I would say, hey, follow your passion, because I didn't even know that there's like jobs where you could just sit around all day doing open source contributions. Like there's jobs like that. There's jobs that are like a mix of 50%, open source and 50% kind of more of a structured activity. At Trail of Bits, it's very research centric, I think a good 20% at least of my time is just going to be spent working on tools, R&D, and everybody kind of has this very research centric attitude. So there's, there are definitely jobs out there that are not just 9 to 5 clock punching things where you're trying to, finish certain tasks, So I would just, recommend following your passion, and that is going to allow you to go deeper into things. That is going to allow you to that's going to, it's a lot more fun and you have a lot more energy learning something that you're passionate about than, learning something because that's the flavor of the day. So that's, maybe something good to end on is follow your passion, kids. The money will come later.
Yeah, I don't think we could end it at a much better place than that. So, Devtooligan, I really appreciate you coming on. This has been a blast of a conversation. And yeah, is there anything else you want to leave our audience with today? Any other places you'd like to point them online or anything else you'd like to say?
Nah, we got nothing to show. I'll send you some links though that you can put onto the show notes that'll have some references to the things I talked about.
Cool. Devtooligan has nothing to show. I love it. That's one of the best answers I've ever heard of that. So yeah, we'll definitely put a lot of links in the show notes. There's a lot of things I think people can take away from this episode with regard to security, leveling up in their career, how they should approach learning new things, and also just like the process of doing an audit or doing a shadow audit if you want to just start getting better at this stuff. So we'll link to all that stuff, and yeah, we'll leave it there. Devtooligan, thank you.
Thank you.